Hey guys, today's video is on the greatest common factor. And we did something similar to this the other day when we did least common multiple. What you see today is going to be kind of same, but not exactly. So please make sure you take good notes. Please make sure that you take detailed, organized notes. So let's begin. Today's objective is to learn to find the greatest common factor of a set of numbers. The greatest common factor is the largest of the common factors. Common meaning same, things they have in common. Factors are a number that is multiplied by another number, also a factor, to give a product. Let's look at exactly what that means. The easiest way I could think of to kind of give you an image of what this looks like are factories make products. For instance, a car factory is going to make cars. That's the product they make. Well, when it comes to multiplication, factors like 7 and 9 make a product, 63. 63 has some numbers that it's divisible by, 9 and 7. Those would be its two factors. So when I'm talking about divisibility, that kind of goes back to factors as well. The number 63 is divisible by are also its factors. So let's move on. Now, there are two ways to find greatest common factor. The first way, method 1, is to list the factors. Now this isn't like listing the multiples that we did before. This is listing factors. And then after we did that, the second method for finding the greatest common factor is to use prime factorization. This looks going to look similar to what we did the other day, just not exactly the same. So let's go ahead and begin. So the first thing we're going to do is we're going to make a list of all the factors for 16 and 24. 16 is going to be 2 times 8, and 4 times 4. We only have to list it once. And 1 times 16. 24 is going to be 1 times 24, and then 2 times 12, and then 3 times 8, and then 4 times 6. You're correct. Now, 5 is between 4 and 6. We'll know that's the last number we have to look at, but 5 won't work because there's not a 0 or a 5 at the end. That's where we go back to divisibility rules. Is it divisible by 5? If it is, then 5 is a factor of it. So now we're going to look at the second way to go ahead and find the greatest common factor, and that's by using prime factorization. So we'll find the prime factorization for 16. Now remember, we're looking for the greatest common factor. That means the largest one. So we're going to use prime factor. Oh, you know what I forgot to do? We didn't find the common one. So let's find all the common ones between 16 and 24. 1 and 2 and 4 is common. 8 is on both lists. It looks like 8's the biggest one on both lists, so it's going to be the greatest common factor. Now we can go to the second method. That would be using prime factorization. So prime factorization for 24 and 16. So let's start with 16. 16 is 8 times 2. 2 is prime. Circle it. 8 is 4 times 2. 2 is prime. 4 is not prime, so we're going to continue here. 2 times 2. Those are both prime. So the prime factorization for 16 is going to be 2 times 2 times 2 times 2. Now the prime factorization for, I'm sorry, let's make sure we got all our 2's in there. Now the prime factorization for 24 is going to be, see, we can do 6 times 4 is 24. Neither one of us is prime, so we have to go a little further with 4, which is 2 times 2. They're both prime. Let's circle them. 6 is going to be 3 times 2. Circle both of them. They're both prime. So the prime factorization we see here for 24 is 3 times 2 times 2 times 2. Now this is where we're going to make a chart like we saw the other day. Now it's going to be pretty similar to it in a lot of ways, but there's at the very end there's going to be something that we're going to do that's a little different. So let's go ahead and make our little chart. Oh, I forgot. Yeah, I need to make sure I cross off all my things. I have 1, 3, and 3 2's. I got 3 and 3 2's. Yes. Okay, now we can make our chart. 16, 24. Looks similar? Well, of course it does. So the prime factors for 16 are 2 times 2 times 2, and the prime factors for 24 are 3 times 2 can go into the other 2, 2 can go into the other 2, and the third 2 can go into the other 2. Now here's where it's a little different. This time all we want is to find the common ones, ones where they both have that factor, where they both have 3 2's, here, here, and here. So we have that one, and that one. Okay, bring those down. Only bring the common ones down now. Last time we used to bring down all of them. This time, since we only have 3 2's that are common, then we're only bring down those 3 2's. We had 2 2 2 2 2 2, but this 3 isn't shared. That means it's not common. That 2, that fourth 2 isn't shared. That means it's not common either. So 2 times 2 times 2, those are the ones they share, the common ones. 2 times 2 is 4, and 4 times 2 is 8. Awesome. So that means we found that, the greatest common factor is 8, which matches what we have here. Awesome. It's really good when both methods find the same number. If you don't, then you've got a problem. You need to go back and fix it. So let's look. What does this have to do with problem solving? How am I ever going to need this when I'm working on problems or things that are going on in my life? Well, here's an example. There's 12 boys, 18 girls in student council. Obviously more girls than boys. The students must form groups to make posters for homecoming. Each group must have the same number of boys and girls. That means if there's 12 groups, that every one of the 12 groups have to have the same number of boys, and every one of the 12 groups has to have the same number of girls. So, what is the greatest number of groups that can be made if every student must be in a group? Well, since we have more girls than boys, there's obviously going to be more girls in each group than boys in each group. We just have to find out what's the greatest number of groups, which is the common factor, that we can make. So, here we go. Method 1 we're going to use is going to be listing them. Method 2 is going to be prime factorization. Awesome. So let's look at method 1. We make a list for 12, which is 1 times 12, 2 times 6, 3 times 4, and I believe that's all the factors we have there. And then let's just do it all right here. I'll show you what we're going to do. So 18 is 1 times 18, or 2 times 9, or 3 times 6. Now the common ones are going to be 1 is in both lists, 2 is in both lists. That's why we circled them. 3 is in both lists, so we're going to circle it. 6 is in both lists, so we're going to circle it. Now, the greatest one in both lists is the 6, obviously. So we're going to box that one because that's the greatest one in both lists, meaning that 6 is the greatest common factor according to our lists for 12 and 18. Now, according to method number 2, prime factorization, let's see what we get. 12 is 3 times 4. 3 is prime. We're going to circle it. 4 isn't prime, so we're going to continue here. 2 times 2, circle both of them. That means that the prime factorization for 12 is 3 times 2 times 2, right here. Now, the prime factorization for 18, 6 times 3 is only one way. You could have done 9 times 2 as well, but we did 6 times 3. 6 times 3, 3 is prime, circle it. 6 is not prime, so we have to continue. That means 6 is 2 times 3. Now, we can circle both those because they're both prime. That tells us that the prime factorization for 18 is 2 times 3 times 3. Now, make our little line right here to keep things organized. Don't mix up what's going on up here with what's going on down here. Make our little chart, 12 and 18. Now, 12's factor or prime factors were 3 times 2 times 2 right here. And 18's prime factors were 2 times 3 times 2, or 2 times 3 times 3. 2 times 3 times 3. Now we can put the 2 under the 2 and the 3 under the 3, but that other 3 doesn't have a common one, so it's going to go over here by itself. Now remember, we're finding greatest common factor. We're only going to circle the factors they have in common, the ones they share. Well, they share this 3 and they share this 2. They both have 1, 2, and they both have 1, 3. There's a 3 here. There's a 3 here. There's a 2 here. There's a 2 here. They don't share that 2 and they don't share that 3, so we're not going to bring them down. We're going to bring down the ones they share. 3 times 2 is 6. Whoops, that's not very good. Is 6. That tells us this matches this. Method 1 matches method 2. Must have done a good job. Now, you don't have to do both methods every time. That's just what we're doing to show you how to do both ways, and you can choose the one that works best for you. So, here's what we're going to do. I have another problem here. In a moment, we'll come back and I'll show you this again. But right now, let's explain how the problems that you're responsible for tomorrow are going to look. So, this is what I want you to see. Here's the problems. Now let's look at the directions. Solve these problems. Your effort and attempts to find the correct answers will be graded. Remember, your effort and attempts to find the correct answers will be graded. I will not give a grade based only, it'll partly, but not only, on wrong and right answers. Now I would love to, I'm sure you would love to get the right answers. However, what I'm really looking for is good problem solving using all of your skills, all of your resources, all of your knowledge, everything you've got. Now remember, this is greatest common factors. So I would bet that's going to have something to do with solving each of your problems. This is the time where I need you to work on them. Make sure you're showing all of your work. Remember, fold your paper into 4s, one problem per square. You can use notebook paper or graph paper, pencil only. And again, I'm grading your effort. Use what you know. Now, here's a little hint. Think about what this lesson was about. That's going to have something to do with what you're going to do to solve the problems. So, let's go back to this problem. This is where I want you to look at it, work on it if you think you need extra practice, then come back and get the answer, because I'm going to have the answer in just a moment. Pause right now, please. Okay, guys, here's the answer to that problem. It's going to be 12 friends will get cookies. Now, if 12 friends get cookies, when you have 36 cookies, each of the friends is going to get 12 times 3, so you can get 3 chocolate chip cookies. And then when I look at 48 snickerdoodle cookies, and there's 12 friends, 12 times 4 is 48, so that each of the 12 friends will get 4 snickerdoodle cookies and 3 chocolate chip cookies. But the answer to the problem was 12 friends. Now, it doesn't matter which way you choose. I would like for you to do both ways for now, practice both ways, so that later you can know exactly which way works best for you. And that's the end of the day. I will see you tomorrow.